Today's live Road to Nodes. We are joined today by our very special guest, Jennifer Abel, who's going to be talking to us about Neo4j deployment in Kubernetes. Welcome, Jennifer. How are you?
Hi, good. I'm good today. Thank you.
Excellent. Well, I don't want to take up your valuable time, so why don't we go ahead and get started?
Yeah, let's do this. Thank you, Allison. So yes, I'm Jennifer Abel, and I work as a data engineer, analyst, and developer at synyx, a IT service company located in Karlsruhe, Germany. We also have a new subsidiary in Newcastle, UK, and we are focusing on open source software development and also like to contribute to it. I'm interested in graph technology, data, domain-driven design, and Kubernetes. I studied a master degree in business and computer science at the University of Rostock, where I first got in touch with alternatives of relational databases as working with ontologies and NoSQL databases. I finally got deep into Kubernetes and graph databases with a customer project at my current employer. There, I realized that Kubernetes is a perfect technology to support Neo4j. This customer uses Neo4j to build a backbone of the messages in its microservice architecture. This allows for cross-domain analysis. I will dive into this in a moment. Some of the project-related problems I picked up in my blog article series on our company blog that is available on synyx.de/blog. Have a look at them for some more interesting Neo4j topics. Today, I'd like to cover roughly the first 3 articles. We will have a look on how to deploy Neo4j 5 community version on Kubernetes, how to migrate from an older Neo4j 4 version to Neo4j 5, and finally run automated backups with help of Kubernetes tools. As mentioned, I got in touch with Neo4j and Kubernetes during a customer project. Of course, the project underlies a disclosure agreement, but I'd like to present the basic idea to use Neo4j to collect data that is communicated in microservice architecture. For the proof of concept, we showed that when domains A, B, and C are talking and receiving messages about things relevant to their domain, for some use cases, it is necessary to look abroad the domain's borders to give it more meaning. Let's say domain A is for offerings, domain B for procurement, and domain C for invoicing. For operational data, of course, everything works fine as this will be handled inside each domain. But for other use cases, for example, legal reasons, it can be necessary to keep data over a longer period of time, or some questions related to a complete order, for example, the time it took from the offer to the final invoicing and payment. Yeah, but why use Neo4j in the first place? Well, traditional databases have fallen short and are more capable of storing data than finding relationships between data points. So for analysis or finding connections and interpreting the data, Neo4j is the perfect fit. With that help, we can find all related and relevant information on a certain order very quickly. So before we start with the hands-on part, I would like to delimit the scope to other deployment and operation options. Despite the option we will have a look on later to run your Neo4j database in a Kubernetes cluster, you may also have the option to use Aura and therefore have the database as a service. This comes with some limits on system options as resource limits that you cannot decide on your own. So self-deployment is a good alternative to manage all the options yourself. Kubernetes allows you to build, run, and manage the application and database on your own. In case you may wonder, why use Kubernetes at all? Well, Kubernetes is a portable, extensible open source platform for managing containerized workloads and services. It facilitates declarative configurations. It is scalable as being a framework for running distributed system, resilient, and takes care of failover and scaling of your application. And for me personally, the possibility to handle some operations without the help of a DevOps engineer is a good thing. So let's start. In this tutorial, I will use a Minikube cluster and the Neo4j community editions available on the Neo4j website. All resources will be available on our company's GitHub repository, which will also be, the link will also be available in the chat, I think. There's also more detailed description on how to set up a Minikube cluster, but to save the download time, I already downloaded and installed it for today. And yes, just have to start it now. So we get away. I already started a cluster by just typing Minikube start. And in the cluster, I already set up two namespaces called Neo4j namespace and Neo4j backup. I set up persistent volumes and related claim that can be used to get storage resources. In general, namespaces help to group resources and isolate them to other namespaces. In this small project, everything could be handled in the default namespace. But since most projects start low and end up in a production environment anyway, for me, handling separation of concerns from the beginning is a good thing. So in this webinar, it helps us to deploy and handle different scenarios as I deployed them to different namespaces. To check for the namespaces, we can just kubectl get namespaces and see that, like a couple of minutes ago, I created these two new namespaces. To use persistent volume claim, which will be used later by the deployment, you need some kind of underlying storage system. The cloud providers provide dynamic provisioning of volumes when you create persistent volume claims using their storage class. This does not come out of the box with Minikube. So for Minikube, we need to set up persistent volume separately so that our application can use a persistent volume claim. And as I said, I also created them already and just checking that they're still there. Well, I created a couple of them. And also, as I mentioned, the persistent volume claims that are specific to the namespace, they're also created. I'll just clear this up for later. Besides that, I wrote and applied a deployment for a Neo4j4 database to have it as a starting point for our migration to Neo4j5. In order for it to work properly, the deployment needs to contain offer service and the database deployment and the reference to persistent volume. So in general, the service making the database accessible from outside the cluster using the web front end or the Bolt connector. And the database deployment itself describes the ports that will be used by this service and to access the database. And well, the persistent volume claim to claim the storage where the data is persisted to. So, and I open up a separate, I can just go back to this. I open up a separate task where we can watch on everything that happens in the Neo4j namespace to like look it up later. And yeah, I already opened this up, so we can just watch on the get all statement for the namespace. And as I said, I already have a database up and running and also the service in this namespace. So yes, and as I also mentioned, we can access this using the browser on this IP address. It's the IP address of the Minikube cluster and the port that will be connected to the database. So I just open this up again. And yes, well, that's the database so far. And with the simple cipher for matching all the data, I put some example data inside. We can see like these 19 nodes and they're linked to each other. And yes, what I wanted to show is that in this lower right corner, left corner, we can see that the server version currently is the 4.4.22 community edition. So this is the point where we wanted to start. So with all this preparation, we can now start thinking about the migration. But before that, let's recap. We now have a Neo4j 4 up and running in our Minikube cluster. This may be a point where some of you step into a customer project and see an older version of a software which already has a predecessor. One good starting point, I think, is with such projects is to renew the database version, but of course keep the existing data. So about the migration, keep in mind that our customer project was a proof of concept and we therefore use the community edition. I guess that is a point where a lot of projects are starting. So depending on the available time to invest, it could be that time passes and newer Neo4j versions are available in the meantime. While Neo4j supports migration to any newer enterprise version from any version, there's also an upgrade and migration guide online in the documentation. For the community edition, it is only possible to migrate between the minor versions step by step. So if you missed some of them, you could either do the handwork or do as we did and use the GraphML export to have a file that is importable by any new version. With the help of the export, you will still be able to rescue the data collected in the past and still analyze it while having new functions and technologies available. This migration path worked for us since we only have nodes and relationships in our graph database and no additional Neo4j specific configurations. The initial situation is that we have a Minikube cluster, namespaces per system volume, and an old Neo4j database running like I shared on the screen. So what we want to do now is, with the help of a cipher statement and the APOC functionality, we will use this statement exporting the data inside the database. So it basically sets a file name. So we call this export Neo4j 4 GraphML and call the export function exporting all the data inside the database. And we don't want to store the node IDs, but keep the types. So we execute this and it gives us back that it successfully created this GraphML file. So what we want to do now is, so this is stored in its own file system. What we want to do now is we copy it out of the cluster. I'm just copying this one because this is a long one. So we do the kubectl, accessing the namespace, copy from the namespace, and inside this namespace is the database. And this is the path where the file is inside the database. So we copy it from there to one of my local folders. And hopefully this will be successful. I think it is. And it should be, yes, copy to this folder. So we just see it in my IntelliJ IDE, but well, we could also open it up here and see like the GraphML definition, but that's not so important at the moment. So we save the data in a GraphML format and are now ready to deploy a Neo4j version 5 database. For this, we need to first remove the old Neo4j4 database, including the service and including the service. So we do the kubectl and reference the namespace, delete the stateful set with the name Neo4j database, and it immediately gives us back that it's deleted. We can also go to our names, to the watching the namespace, and we see that the database is now gone, but still the service is there. So we need to delete this service separately, Neo4j namespace, and delete the service with the name Neo4j service. It's also deleted, and we see now that there are no resources in our namespace now. So for the Neo4j 5 database, there are some options for running the Neo4j 5. So as previously mentioned, you could use Aura and import your data there. So with the help of the GraphML, this will also be an easy switch as it can be imported there. If you want to run on Kubernetes, you could either use the Helm release that is available on the Neo4j Download Center, or could deploy it by hand on your own. In general, Helm is known as the package manager for Kubernetes. The original idea was to provide a better way of managing all YAML files that are needed to run a project on Kubernetes. So this means that the Helm chart install the complete dependency tree of deployments, services, and claims that are needed to run the entire application instead of applying all files separately. So it is advised to use, especially when using the same template in more than one project. But then you probably need some time to get ahead of the little bit more complex structure to run and customize. For me, this means use it if you understand what you're doing. So the second option, to write the deployment myself, was my preferred way. Also from an earlier versions of Neo4j, Helm charts were not available. So when I started to learn about Kubernetes and deployments, it was much easier for me to understand what was going on in the first place, with everything set on my own, not handled by some predefined parts of a Helm chart. And as developers, I guess we like to understand what we are doing, right? Later on, it might be no problem to switch to a Helm chart and define all the necessary variables to run the database in the same way. But for me, it was a good starting point. Before we have a look at the Neo4j 5 deployment, I'd like to have a short thought on security. For the Neo4j 4, I just left the credentials to their defaults. Well, I was forced to change the password after the first login, but that wasn't very individual choice. For the Neo4j 5, I would like to use Kubernetes inherent secrets to define the credentials for our database. Short side note on this, I will check in the secrets to the repository for you as well. Of course, this is not what you should do in a production environment. My suggestion would be to use the help of Kubernetes tooling and seal the secrets to make them available in an encrypted way in the repository. Since this will be a little over our scope, we will just handle the unencrypted secrets. The secrets are defined, okay, I'll make this a little bit bigger. So the secret is defined in this Neo4j secret.yaml file. And it's, as I said, kind of secret. and will be deployed to the Neo4j namespace with the name Neo4j secret. And I set up 3 credentials. So basically the password, the user, and also the authentication connecting the password and the user. So what we will do is we will apply this file to our namespace by doing the kubectl apply -f, selecting the file. Yeah. Then immediately says that the secret is being created. We can check for the secret by kubectl get secret, and don't forget about the namespace. Well, some options to handle namespaces without saying the namespace each time, but since we're using different one later, I'll just keep it. And we see that about 30 seconds ago, we created this secret Neo4j called Neo4j secret, so it now can be used by our deployment. So now let's have a look at the Neo4j5 deployment. I also prepared a file for it and make this a little bit bigger. Maybe also get, yeah. And I go through it step by step. So the first part of this deployment file is the service. The Minikube virtual machine is exposed to the host system via a host-only IP address. We can check for this IP using Minikube IP. And this is the IP address we saw before on the browser that we use to access the database. So in general, any service of the type node port that we use can be accessed over that IP address. The default node port range is from 30,000 to something about 32,000. And this can be adjusted, but I just picked something within the range. So what we do is we link the ports that are available at the database to the node ports that the Minikube offers. So this is the port from the database. This the name is the Neo4j port, and this is the node port that we link to in the Minikube cluster. And in general, this makes the database accessible through this service. The second part of this description is the stateful set. With Kubernetes, you have the option to use a stateless deployment or a stateful set. Well, to prevent data loss on pod restart, stateful is what we need to go for here. As in a Kubernetes environment, this will come with a unique identity on network and storage. So that will be reused over time. So if the pod restarts, we can still access this storage. And this database stateful set will also be deployed to our namespace and given the name Neo4j database. For the specifications of the container, which will start here, I will just explain some of the things here before. So as I said, the database also knows about the service. So we reference the service here, having only one replica of the database. And before we start this database container, we also make usage of an init container to pre-handle things on container startup. And we use this to copy the APOC library that we need to use for exporting and importing GraphML. Because with the image of the Neo4j 5.12 that we use here, it already includes the APOC library, but it contains the library in the labs folder. And for the database to use it, it needs to be in the plugins folder. So what we need to do, or what we do, is we use this init container and do a command to copy the file from the labs folder to the plugins folder, and are then able to use it in our database in general. So we also mounted this plugin folder as a volume so that it's not destroyed after the container is finished, so that we can still keep what's inside this folder. And well, this will be reused by the real container of the database. So the container itself also uses the same image. And as I said, it will define the 2 ports to connect to it, for the Neo4j port and the Bolt port. And also in this container description, we need to reference the secret that we just created. So the container will pick up this information and use the password and user we defined in this file. And yeah, with this password set, you can access the database then. Furthermore, we defined some environment variables for the container that will be picked up by the configuration file. They changed a bit. They always change a bit from the different versions. So they change a bit from 4 to 5. I hope I caught everything with these 4 variables. So what I did is I whitelisted the GraphML export and import functions of the APOC library. And in addition, you also need to allow the file import and export separately. So set these 2 variables to true. And I also put in a variable for validation, as there are a lot of things that change between 4 and 5 I couldn't pick up already. So what this makes is still make it possible to access things. Yes, and as I said, we also need volumes. We have one for the data, so that's where all the data will be saved to. We have one for the backup, where the backup folder or our backups will be saved to, and also persisted the things in the plugins folder. So when we restart the container, it doesn't have to load the plugins again. So yeah, and yes, in the lower, the volume mounts will be referenced, will reference the persistent volume claims, and that's where the data is persisted to. And as you can see, like in this repository, I also have like the minikube files for the namespace, persistent volume, and persistent volume claims in it. So you can, whenever you want to use this as a starting point for your project. So as I explained this, I just can apply this file for the Neo4j version 5. Deployment file, so that's the name, and just apply it, and it says it created the service and it created a stateful set. So let's have a look at the namespace, and we see that, well, about a few seconds ago, the database and the services are up and running. After applying the deployment, it takes a short time until the service can be reached. So let's check if, well, it's not already reachable. So it will be the same as you saw before. It will be the same URL. So, well, let's wait some time. To find out about the required URL I showed you before, you could also check this again using then requesting for the URL, and we see that are these two, and I think they're the same. Okay, yeah. So this works. It requests for our newly set password that was in the secret file. So I put it to 1, 2, 3, 4, 5, 6, 7, 8 as super creative password. And hope this will connect to our Neo4j 5 database. Let's check this. Yeah, so this new version is Neo4j 5.12 Community Edition. So yes, we have the new database version up and running. We can check, we can check for data inside the database, which of course we don't have yet because we just deployed it. So what we do is we did a reverse procedure from what we did before and just copy the data from the file I saved. Remember, I put it here and just copy it to the backend folder again. So yes, this should be copied. And what we do in the front end is we just call the APOC function of the import, which is called import GraphML, the name of the file, and that it should read all the labels that are available in this GraphML and just execute it. It says that it is successful, and as we already can see, it kind of it created 19 nodes and 16 relationships. So if we rerun the match statement, we can now see our data inside the Neo4j 5 database. So let's quickly recap. We first had a Neo4j 4 database, exported the data to GraphML, removed the version 4 database, deployed a version 5 database, and restored the data. In the last part of this webinar, I'd like to show you a method for backing up the data in your Neo4j community database with the help of some Kubernetes tooling. As normally backup is an enterprise feature, I will give you a feasible way of automatically backing up your data. So let's clear this up and yeah. So first, a few words on backups. Backup and recovery means to create a copy of your data to prevent your organizations against data loss. So a proper backup will be saved to a separate store. In case of a system failure or problematic event, this data can be restored and therefore recover the data to an earlier point in time. In our customer project, we used MinIO to store the data. It is a high-performance S3 compliant distributed object storage that is 100% open source. You may use it on every public and private cloud or Kubernetes distribution. The MinIO storage system is able to run on minimal resources, which makes it handy also for small projects. In my blog post, I gave some additional instructions on how to handle the backup to MinIO S3 buckets, as Neo4j can write directly to it. For this webinar, I decided to simplify the example a bit and just explain how to use the Kubernetes tooling for triggering automated backup. But instead of writing it to a MinIO bucket, it will be written to its file system, as the MinIO setup is beyond the scope of this webinar. As I mentioned, I set up a different namespace for this use case. So we close this one up and now start watching on the Neo4j backup namespace get all and watch this. For the backup part, I already have a Neo4j 5 database up and running in the Neo4j backup namespace with some example data inside. I switched the number of the ports super creative to 30,047 instead of 74. So I already have this open in my browser. As I said, it's a 512 database as well. And with the match statement, we can check I already placed some data inside. So that's the data we want to back up and save. And besides just writing the statement like we did before when exporting the GraphML to the web front end, Neo4j also offers a HTTP API where we can place the cipher statements to the Neo4j transactional endpoint. So the endpoint will send back an answer using JSON format. For more information on the HTTP API, there is a page of documentation on the web, of course. But as an example for the usage, we could place a curl statement from our terminal. So go back to our terminal and place it using the HTTP API to request a number of nodes inside the database. I prepared a statement. I tried to type it before, but made some mistakes. So I'll copy and paste this again. So what it contains is we curl and post the statement to our Minikube IP address and accessing through the node port. And this is like what is described in the documentation, that with the DB Neo4j commit, we can access the HTTP endpoint. And we give some more header information that this curl statement contains some JSON information. And we also give the authorization, like this is the base64 encoded password and username from our database. So for the example, I used the same secret file as we used before, so they're similar. And for the data, well, it gives some JSON, JSON looking statement, and it contains our cipher requesting the number of nodes inside the database. So yes, we can execute this directly from the terminal, and we receive an answer, so result answer, that with count n we get like 19 nodes back. And in here we also can check the number of total nodes. So this is also 19. So yeah, that's what's inside in our database at the moment. So let's go back to the presentation. For the backup, we make use of this and place a similar statement as before to export as GraphML. I will not place it now using the terminal, but instead write it as a command that will be executed by my Kubernetes Cronjob. To give an overview, I will create a cron job that will do a GraphML export on a regular schedule that will be placed to the HTTP API of our Neo4j 5 database, and it will trigger a backup in its own file system. Of course, that's the part that you can change, that this process can trigger a backup to like S3 or whatever other storage you want it to. So let's have a look on the deployment. This is here. Close these and on the deployment of the cron job. So it's also the resources are available for the database itself that I already deployed and the secret. So that's the file for the cron job. We set up a cron job that will be named Neo4j backup, and it will be deployed to our Neo4j backup namespace. The cron job will be scheduled to be executed every day at 2 a.m. And if the job fails, we will keep a single history file so that we can analyze it afterwards, what happened, what went wrong. But I will not keep any successful jobs because I don't think I have to analyze them. The concurrency policy field specifies that I don't allow concurrent jobs. So if a new job run should be started and the old job is still running, it will not start a new job as I forbade this. The actually executed job will follow this job template. It will use a Bitnami image, which is able to use curl statement. As mentioned, the GraphML export will be executed in the comment section. So here is the comment again. It's like we also open up a shell, and in that shell we place the curl statement that is similar to the one we had here, but now instead of just like requesting the number of nodes inside our database, it just contains the with statement, calling it the export GraphML function, and yeah, placing also authorization and placing this to the HTTP endpoint. So yes, that's the cron job. And well, let's see if this works by applying this job to our Minikube cluster, to our namespace. So we have for J5 backup job YAML. That's how I called it. And we see that it created a cron job. You can now go to our namespace and see beside the database, the service, and the stateful set, there is now a cron job available for 14 seconds. And well, of course, I will not force you to wait until the job is executed at 2 a.m. in the morning. So what we can do is we can derive a single job from the cron job for example purposes. So I will do the kubectl defining the namespace, create a normal job that will be from the cron job. And this cron job is called Neo4j backup. And the new job will be called Neo4j backup once. And it says that there's a new job created. We immediately check. Here also the job is created and it made up a container that, well, was created, then ran, and it's already completed as the GraphML file currently is not that big. So since it's completed, we might wonder if it was actually successful. Well, it says that it's successful, but I will give the proof to you by accessing the backend of the, well, we could copy the file from there, but I just show you something else to access the backend of the database with opening a shell. So we're now inside the database. This is like the starting point, and the file will be in the import folder. And we can see, well, it's like the UTC time zone. So like about a minute ago, this backup GraphML file was created by us. So yes, the backup worked. And Yeah, so to wrap up, what we did today is we explored some of the Kubernetes tooling and how it can support us with our Neo4j deployment, especially if we're running a community edition. We started off by deploying a Neo4j version 4 and wrote some data to it. We saved this data to a GraphML file to migrate to a newer version, Neo4j 5. We finally set up a cron job which stores the data automatically on a regular basis for backup and recovery purposes. Yeah, so that's what I wanted to show you today. Thank you for your attention. If you have any ideas on improvements as well as questions, I'm happy to answer them now, or you can contact me on LinkedIn. And yes, now back to Alison. I hope you already collected some questions.
We do have a couple of questions. First of all, Jennifer, I just want to say thank you so much. What I really appreciated about this is how many really useful tips that you had. So even from setting up the namespaces with the idea of growing at the beginning to teasing using min.io for storage. There's just so much practicality in the way you went through it. And I just really appreciated that and your expertise in Kubernetes to begin with. We do have a couple of questions, some of which I think got answered, but we'll go through those. We had one person who asked, what are the advantages of using Kubernetes to enable this scalability versus just making using 3 different instances? So just talk about that a little bit for folks who might not be as familiar.
I'm not sure if I understand the question completely. So about 3 different instances, what is meant by that?
So the question specifically says, which is better, using 3 instances and making a cluster, or using Kubernetes to enable high availability?
Well, so I'm not really sure about this because I'm not very, very deep into the Kubernetes, but I think like if you have more instances, well, it's depends on the resources, I guess. If you have one Kubernetes cluster or have different instances for running it.
Got it. The next question that we had was about, and I think we can answer this together, but they were curious about, one is if they send the, through the HTTP API, if they send a cipher statement and there's an error, will you see that? Will that come back? And it looked like it would. And so they just wanted some confirmation of what that would look like.
I think we have it there. So yeah, I wanted to mention this, but I forgot. So we kind of have the result and then the data here, but also like the error section. So actually when I did this, I got a lot of errors in the first place. So trying this for like 2 days. So, and then you will receive a lot of errors if you do it the wrong way, because like for the statement I place here, I just, you like have to be very careful with the, what's this actually? I don't know. For the question, well, these 2 dashes, you have to be careful and like escaping those and be careful when setting up this. So if you don't set up it correctly, you immediately get a lot of errors and well, you get them back with this error statement.
And then the last question came up, which is about it. Let's just say you want to change a data model or you want to make some kind of changes in the database. I think one of the questions folks had was this ability to, on your right-hand side where you were showing like how to actually pull up that database connection, if you wanted to go back and show them where that lives so that they can actually see what that local host is. So when you actually want to access the browser, how can you look into the code in the terminal to see where that browser, where they should find that browser?
I see, yeah. So this was like to find out what URL it is you have to connect to. Is like for the Minikube cluster, and I also think this is possible for like the other clusters, like if you have normal Kubernetes cluster, let's type something. I'll just clear this up. Minikube name. Oops, it doesn't want the namespace anymore. Okay, so I just type it. We have something wrong written, but it doesn't use it anymore. So we can say the service and the Neo4j service and then minus URL should give us the URLs that are assigned to this service in the namespace. So you can also like click it from here, and that's like where you have to connect to. But like this URL is the Minikube URL, and I think for your different cluster, it will give you the different cluster. And like this port is the one we defined in our deployment. So that's the one you should know. But to get like the IP address, you could use either this or, as I said before, use the Minikube IP, which will give you the same IP address.
Thank you so much. The last question we have is more of a general question about it. Do you have any insight about getting started in DevOps?
Whew. Well, I did a lot of YouTube tutorial for beginning as well. And I actually think the Kubernetes documentation is very, very good. But it's not like for me not to read like as a book, but to look everything up you don't know. So yes, I think there are a lot of good YouTube tutorials outside there. And I think that's a good point to start.
Excellent. Well, just put it out there. If anybody has any other questions about what Jennifer has covered today, I also think it was so great to show how to do that backup in Community Edition. We, obviously not everybody is using Enterprise, and to give that tidbit about how to back that up, I think that was a really great takeaway for those who are working in this open source space. So I wanted to thank you for that as well. Just a reminder to everyone that we do have Nodes coming up, which is our conference, which is going to be next week. I can't believe it's already coming up. So we hope to see everybody there. If you have any questions, I'm going to drop Jennifer's blog back here in our sorry, I went to another place. I'm going to drop your blog in there, Jennifer. If you wanted to provide your LinkedIn address, we can certainly drop that in as well. So if anybody wants to get in touch with her for follow-up, otherwise, we just want to thank everyone for coming and being with us today and giving us all of your questions. We've got lots of positive comments coming back through in the chat, thanking you for all of your information and your advice on DevOps. So Jennifer, thank you so much. We look forward to seeing you very soon, and we will see all of you at our next Neo4j Live. Thanks, everyone.
Thanks, Allison.